Hey guys, welcome back to C4U. Here I am with another new video of important name reactions. In this video we'll be saying formylation reactions part 2. Two reactions I'm gonna take in this video, which are Gattermann salicylaldehyde synthesis and Gattermann-Koch reaction. So here is the first reaction, Gattermann salicylaldehyde synthesis. In this reaction, phenol reacts with hydrogen cyanide and HCl in presence of AlCl3, which is used as a catalyst. It yields salicylaldehyde as product, and the reaction also works on benzene and phenol ethers. The mechanism of this reaction goes via formation of iminium cation intermediate. The reaction is also known as a formylation reaction. Of course, it's part of formylation reaction. So here is the reaction of Gattermann synthesis. Phenol with HCl in presence of AlCl3, and hydrolysis will be needing water. So the product is salicylaldehyde when we'll be using phenol, and if you'll use benzene instead of phenol with the same reagents, we'll be getting benzaldehyde as a product with benzene. Okay, and if we'll be using anisole, you'll be getting 2-methoxybenzaldehyde. So here is the mechanism of reaction. First, HCN and HCl works together to give chloromethenamine. So it happens like this, and then this imine will react with AlCl3 to form a cation. Here AlCl3 is a Lewis acid which has a tendency to accept the electrons. It accepts the electrons from nitrogen and make it electrophilic. So iminium cation is an electrophile in our reaction. We have phenol, which is nucleophile. So this nucleophile and electrophile will now come together and they will react. So phenol being a nucleophilic, that means it is a electron rich species. So it will donate the electrons to the carbon, which is being electrophilic due to the positive charge on nitrogen. So here is the next species. Oxygen will get a positive charge and we will get NHAlCl3 minus. So now here with loss of AlCl3, as AlCl3 will donate back the electrons to nitrogen, and we'll get NH2 here. So now in the next step, lone pair of nitrogen will form a double bond with carbon, and nitrogen will again get a positive charge. Chlorine doesn't go anywhere outside from the reaction. It just play a role of counterion for iminium cation and forms a iminium salt, which on hydrolysis is going to give salicylaldehyde. Mechanism of further step I am discussing in detail here. So you can see it would go like this. So with minus of HCl, you will get OH at that position, H2OH. Okay, so here per carbon has 2 electronegative atoms, so they can't be. So with minus of NH4Cl, तो NH4Cl कैसे आता है? HCl from the previous step and NH3 from this step is going to make a salt of ammonium chloride, and here the formylation occurred. Now the one most important step, that is the re-aromatization, is to be happen, and we are with our final desired product, that is the salicylaldehyde. Okay, so this is what the mechanism of Gattermann reaction to form salicylaldehyde from phenol. Important about the reaction is the reaction can be simplified by using zinc cyanide instead of the mixture of HCl and HCN. The reaction works on benzene and phenolysis also, and the most important is due to the toxicity of cyanide, the reaction is needed to be modified, and the modified reaction is what the next subject of our video, which is the Gattermann-Koch reaction. So the reaction is like benzene reacts with CO and HCl in presence of AlCl3 and gives benzaldehyde as a product. The most important fact about the reaction is, unlike to the Gattermann reaction, this reaction doesn't work with phenol and phenol ethers. So here is the Gattermann-Koch reaction, where our benzene is going to react with carbon monoxide, HCl, in presence of AlCl3, and going to give a benzaldehyde as a product. The formylation occurs on the benzene ring. Okay, so now let's see its mechanism. Here is the mechanism. Okay, carbon monoxide will react with HCl and they will work together to give formyl chloride in this manner, and this formyl chloride will now react with AlCl3. Again, AlCl3 is a Lewis acid, accept electrons from oxygen and form such a bond. So here we have electrophile of the reaction. We have benzene, which is itself a nucleophile. Benzene is electron rich one, and yeah, this electrophile in this reaction is capable to accept the electrons from the benzene ring. So here what happens is, again rearomatization will give a benzaldehyde. So minus of HCl, chlorine from the previous step will take the hydrogen here. So minus of HCl will give benzaldehyde as a product. Now if one will ask you to do the same reaction with phenol, that means phenol with carbon monoxide, HCl and AlCl3, or any phenol ether like anisole, ethoxybenzene or anything, so you must have to say there there will be no reaction. There will be no product formation. So thank you guys for watching this video. I hope you guys like this video. So if you like, please like, comment how you feel this video. Please share this video to your friends. Subscribe to C4U and press the bell icon to get new videos. Thank you very much.